Hello everyone, welcome to my YouTube channel. My name is Amrita and I'm currently pursuing my engineering in Sri Venkateswara College of Engineering. Today I'm here to talk about mesh and loop analysis. Mesh and loop analysis. Mesh and loop analysis are two techniques used in electrical circuit analysis to determine the currents and voltage in a network of resistors, voltage sources, and current sources. Mesh analysis is a method used to find the current in each loop of planar circuit where a loop is any closed path. Identify a mesh is a loop in the circuit that doesn't contain any other. Identify the number of meshes. Assign Kirchhoff's. For each mesh, apply KVL around the loop, which states that the sum of the voltage drops around any closed loop must be equal to 0. Write mesh equations. For each mesh, write the KVL equation using Ohm's law for the resistor and voltage sources. This will give a set of simulation equations. Mesh is defined as a loop with no other loops within the circuit. In this case, mesh currents are used as variables instead of currents to determine the overall circuit analysis. As a result, the technique requires a small number of equations to solve. Mesh analysis is used in circuit to determine unknown current values using Kirchhoff's voltage law. Mesh analysis is based on current loops in a circuit. The process of analyzing circuits can sometimes be difficult task to do. Examining a circuit with the node or loop methods can reduce the amount of time required to get important information on a circuit. These analyses apply Kirchhoff's law in a step-by-step approach to solve for unknown voltages and current. Once these values are obtained, further information such as electrical power can be analyzed. The node equations are obtained by completing two things. Express the current through an element in terms of the node voltage. With the exception of the reference node, apply KCL to each other node in the circuit. Figure 4 below shows an example of a DC circuit with current and voltage sources. It contains three nodes A, B, and C as well as the reference node at the grounded connection. Note that the direction of the probe arrow is dependent on the direction you move to connect the nodes. For example, here the top node was connected to the bottom node instead of the bottom connecting to the top. So the arrow points downwards. It is an assumption made by the program. Nodal analysis is used for solving any electrical network and it is defined as this method is also known as the node voltage method since the node voltages are with respect to the ground. The following are the three laws that define the equation related to the voltage that is measured between each circuit node. Electrical network analysis. The analysis of electric power systems could be conducted using network theory from two main points of view. An abstract perspective, that is a graph consists from nodes and edges. Regardless of the electric power aspects, most of these studies focus only on the abstract structure of the power grid using node degree distribution and betweenness distribution, which introduces substantial insight regarding the vulnerability assessment of the grid. Through these types of studies, the category of the grid structure could be identified from the complex network perspective, that is, single case, scale free. This classification might help the electric power system engineers in the planning stage or while upgrading the infrastructure. Example, add a new transmission line. To maintain a proper redundancy level in the transmission system. Weight graphs that blend an abstract understanding of complex network theories and electrical power system properties. Thank you for watching my video.